All right, so the first problem is that we have a horizontal surface and then we have a block sitting on it and an additional another block sitting on the block. We call this block A and block B, and both of them are tied to a pulley via a string, a rope, right? And the pulley has an acceleration A rightwards, and we have been tasked to find the tension in the string. Okay, the tension in the string here and here would be the same because we are taking a massless string. Okay, so the tension, we just need to find one and then we would know the other. Okay, that is more or less the problem. So there are a few more things given about this problem, that MB, the mass of block B is larger than the mass of block A. All right, the rope is massless, and there is no friction between the surface, this surface, and block B. Okay, so there is no surface, there is no friction between this surface, and there is a force of friction F between these two surfaces, right? All right, so we need to find tension. We start with the free body diagram first of the block B, both blocks. So the free body diagram. So the forces, the weight weighing down of block B, right? But also the weight of the second block is weighing down on block B, okay? MAG, right? Although I don't know if this is going to be very useful. And then a normal force upwards, and then a tension T rightwards. Okay. Any other force that is acting on this object B? This is object B.
Friction
Force of friction with direction
towards the left.
towards the left. Yes. Yes, but how? Why?
Sir, उन्होंने बोला कि the block slide without friction. So I don't think we have to keep in mind the friction.
No, the block slides without friction is B on this surface slides without friction. This is 0. But this friction is not 0. So someone
Sure.
who said there would be a force of friction on block B leftwards, I want to hear from them how. How did they arrive at the conclusion? So does everyone agree that there is a force of friction acting on this object thiswards? Is it very clear? Is it very obvious, or any
So
opinions?
wouldn't the friction only act on block A, or because block B's motion is not like directly related to that friction?
Yes and no. Well, let's see. So let's demystify this situation in a much more simpler situation. Okay. So if you have two surfaces, any two surfaces, and if they have relative motion, so that is the condition. Remember, relative motion. So it doesn't matter which surface is moving. Okay, so they just have to move with respect to each other. So let's say that they are moving in this fashion, that the The lower surface moves in this direction, upper surface moves in this direction. And we don't know, let's say this is Earth, then we don't know. So yes, so and we know the mass of this, for example, this object. So there would be a force of friction between these two surfaces. Okay, we can find out the friction of this lower surface on the block using this relationship. That if we can figure out the normal force, then the friction would be simply mu times the normal force. That would be the friction, and it would be acting on this object in the opposite direction of motion. Okay, a force of friction acting on this object in the opposite direction proportional to mu n. But now if we were considering the motion of the lower surface, the lower object here, there would be an equal and opposite force of friction acting on this object as well, and that would be in the opposite direction. So the force of friction on the lower surface would act in this direction. Does it make sense? The force of friction on both objects, if the two objects are sliding against each other like this, if the two objects are sliding against each other, you can't say that the force of friction is only acting on the one block. There would be force of friction on each of them. It would be equal and opposite direction. Okay, it again makes an action reaction pair. So let's say because you're given that the mass of the lower object is larger than the mass of the upper object, so more likely that this is going to have larger acceleration in this direction. So it's going to slide on this block, and the motion of this block is going to be in this direction, and there is going to be a force of friction on this block in this direction. But when this block moves in this direction, it exerts an equal and opposite force of friction on this block in this direction. Is it all right? Do you get
तो
it?
सर राइट की तरफ टेंशन और फ्रिक्शन का सम होगा.
Yes. All right. Now we have on block B, we have tension and we have the force of friction. Okay. Now we do the free body diagram. Free body diagram of object B. So it's normal force, and you have to keep in mind that the normal force here, let's call it B and let's call it A, they're different. This normal force is sum of the weights of the two objects, and this normal force is just equal to its own weight in this particular case. Okay, and MAG and a tension rightwards and a force of friction leftwards. Okay, so that's it. That's the free body diagram, and now you can. We are not really interested. There is no acceleration in the vertical direction, so it's not interesting. We are only
Sir?
interested in, yes.
जो फ्रिक्शन दो की वैल्यू होगी वो दोनों के लिए सेम होगी.
Exactly, this it has to be. It's an action reaction pair.
ठीक है, थैंक यू.
So let's write the equation in the horizontal direction for this. So we have tension, we have friction equals M A A A. Oh no, this is B, sorry. This is object B. Okay, and then you have T minus F M A A A. All right. So now we have to find tension, okay? And we don't know the accelerations, A and B. So we cannot really solve these two equations unless we have some additional information. And that additional information is the acceleration of the pulley. Okay. If the pulley is accelerating and this rope can readjust, right? It can adjust depending on the ratio of their masses and the friction between the two. One can accelerate more and the other can accelerate less. So the string can adjust, but its length remains constant. All right. So if you write the position vectors, or if you write the length in terms of the position vectors, or just write the length in terms of the the positions of all these objects, something like this. Let me say how best to do it. You could probably just set a coordinate system somewhere. Let's say you set a coordinate system here, and then you do the distances. You get XA, you get XB, you get XP, okay? Positions for all three things. And then write the length of the pulley as a sum of these quantities. Can you figure that out yourself? Can you write the length in terms of these three quantities? And if I give you the radius of the pulley, R, okay, what would be the length then? Can someone help me figure that
Sir,
out?
what is XP?
The position of pulley. Okay, the position of the x coordinate of the block A, the x coordinate of block B, and the x coordinate of the pulley. So what would be length in terms of these quantities?
XA plus XB plus R, or 2 pi R.
No, XP minus XB, right? XP minus XB would give you this segment, right? XP minus XB would give you this segment. XP minus XA would give you this segment, okay? And pi R would give you this segment. Does it make sense now? All right, plus pi R. Now with time, this remains constant. The length remains constant. So if you take the double derivative with respect to time of this quantity, this would go to 0. This would also go to 0, it's not changing, okay? And then after taking the double derivatives, taking the time derivative twice, you would have found a relationship between the acceleration A, acceleration B, and the acceleration of the pulley. They have to be related. Can you find it? Can you find this? Can you take the time derivative and find the acceleration of the pulley in terms of the acceleration A and B?
सर अभी आपने कहा है कि आपकी जो डिस्टेंस ऑफ पी और ये एक्स पी एक्स बी और एक्स ए सब कांस्टेंट रहेंगे, तो जब हम इनका पहला डेरिवेटिव ही लेंगे तभी ये जीरो नहीं हो जाएंगे?
No, I said that the sum there, this thing is constant. L is constant. They can readjust. X, P, X, A can readjust. They change because everything is moving rightwards. But is not moving right. It is like this. If you're pulling on something with a string, right? Okay, the length of the string is constant. Okay, but the relative positions of everything is changing.
Right.
And it would be trivial if the string was not attached to a pulley, because then all the accelerations would be the same. Okay, but the string is attached through pulley, so it can readjust. So these three accelerations are not related to each other straightforwardly. Okay, there is a non-straightforward relationship, let's say. So XA is changing with time, okay? And its ratio with XB is also changing. Okay, and their ratio with xp can also change. So the only thing that constant is the length of the string. So we've just written the length of the string in terms of these quantities. Now, if you take the derivative, L would be 0, but this derivatives would not be 0. This would become VP, VB, VP, VA. This would be 0. And then the next derivative gives you AP, AB, AP, AB, and then you can deduce the relationship. Can you do that quickly, please? It's not that difficult.
सर
Sir,
मेरे पास
2AP plus 2AB, 2AP equals 2A, AB plus AA.
Yes. So the acceleration would be, what is it? AA, AB equals 2A. Okay. Now you have 3 equations and you have to find T. Can you find it now from here? These 3 equations, solving them simultaneously. You have to
Sir,
eliminate. Yes.
से पता है कि वो जो acceleration of pulley है वो A के equal है.
Mm-hmm. So A is known. All you have to do is eliminate AB and AA, these 2 accelerations, and find the acceleration in terms of the friction and the acceleration A and the masses. A is a known, so you don't have to eliminate that. You have to eliminate AA and AB. It's pretty straightforward. If you just add these 2 equations, you see, the friction term would be canceled. And on this side, no, that wouldn't be very simple, right? No. Well, figure that out. You can find out the simultaneous equations yourself. Okay, so next problem. So we have a car entering a turn. On a road with a bank, which is elevated by angle theta, all right? And the car is right here. Okay, so this is the car. And so this is the radius of the bank, or the turn, if you like. R is the radius of the bank. And what we need to find out, and the force of friction between the tires and the concrete or the asphalt is mu. The coefficient of friction is mu. 3 things given. And what we need to find out is what is the maximum and the minimum speed that if the car enters this turn, it does not slide off the ramp or off the bank, right? Both the minimum speed and the maximum speed. Can you mute, please? Someone is unmuted, I think. So let's write so start with the free body diagram, right? The free body diagram of car. Can you help me through chat identifying all the forces? Please, quickly. Good. mg. What other force? Next. Friction. Which direction friction? Which direction? along the surface, it would be parallel to the surface of the bank. And how about normal force? Normal to the bank, right? And what else? Which other force do we have here? Hmm? Do we have any other force? Wouldn't the F be in the opposite direction? FB, what is F? Okay, FB in the opposite direction. So, so let's say that we are talking about that the car might slide off the bank in this direction, and we take F in this direction. Okay. For the time being. Okay? So the friction we will see that about the direction of friction we will talk about in a minute. Okay, this is especially interesting in this context. But there is going to be another force. Let's say that the car enters the ramp with a speed v. Okay, there is going to be an acceleration v square over r. Okay, and there is a force that is causing that acceleration. Is centripetal force Fc mv squared over r, the radius of the ramp, and m is the mass of the car. Right, and its direction would be this. The Fc is going to act in this direction. Okay. And now we choose the coordinate system in such a way that this is Ex, okay, and this is Ey. All right. So in this coordinate system, we write down all the forces. So we would have, if this is angle theta, see this. If this is angle theta, then we can resolve weight in a component in this direction and a, yes, that would be y. So along y-axis. Okay. So the component of weight acting in this direction would be what? Mg sine theta. Right?
सर नेगेटिव mg sin थीटा नहीं होगा?
जी
नेगेटिव mg sin थीटा नहीं होगा?
जी बिल्कुल, negative mg sine theta. Okay, and then the weight acting in this direction would be mg cosine theta, and this would be negative as well. Okay, the normal force would be simply is along x-axis is positive, and it would be equal to mg cosine theta. Okay, and the force of friction is just in along a coordinate system, so we don't need to worry about that. And then we have to make components of this quantity as well, Fc. So Fc would have a component in this direction and a component in this direction, right? So which component of Fc is cosine theta? This component, right? This is Fc cosine theta. Please make sure that these components are correct because I may have made a mistake here. Fc sine theta. Does it all make sense? The whole free body diagram? All right, if it does, then I'll just write the equation, all the forces in along the x-axis and the corresponding acceleration, okay? So let's identify all the forces. We have Fc cosine theta, positive x-axis, this force, minus mg sine theta, this force, the weight along the surface of the bank, minus mg sine theta, and the force of friction opposing let's say the force of friction is also minus, okay, is in this direction. That would be mu n, right? The force of friction where n is the normal force. Mu n equals, so I have three forces. The centripetal force, or the centrifugal force, if you like, is a action reaction pair. And then you have the weight, and then you have the friction. Equals acceleration in the x direction along the surface of the ramp. Okay. Now, can I substitute two quantities here? What is Fc? mv square over r. So can I just write here mv square over r? Okay. And also, what is n here? What is n?
mg cos theta.
Mg cos theta. All right. So this is more or less the equation.
Sir, but Fc sine theta is also acting vertically downwards. So
mg cos minus mg cos theta minus fc sin theta होगा.
जी एक मिनट mu mg cosine theta is equal to m a x. अब बताएं जी.
सर जो n है उसकी अपोजिंग आपके पास दो फोर्सेस हैं. एक आपके पास m minus mg cos theta और दूसरी f minus fc sin theta.
Oh yes. So the normal force is not simple. Yes. So the normal force, yes, the normal force is very good. Is mg cosine theta plus fc sine theta, right? That's what you're saying, right?
Yes sir.
Fc sine theta. Yes. So let's correct that then. And they would be positive, right? Because they would be mu mg cosine theta minus mv square over r sine theta. MAX. All right. So it's fine now.
सर mg cos theta के साथ भी माइनस लगा दें. बीच में प्लस लगा दें और माइनस म्यू कर दें सर.
Yes. Yes. Now this is correct, right?
Sir, calculating in the diagram and finding m minus mg sine theta and minus mg cos theta, which angle have you taken as theta, sir?
Can you come again?
Sir, in the free body diagram for minus mg sine theta and minus mg cos theta, which angle have you taken as theta in the diagram?
I think it's this angle. No?
Okay, thank you.
Now this would make sense, right?
Yes.
Okay. All right.
Sir?
So now, yes.
Why was mu made minus?
Oh, because the force of friction is acting in this direction. Okay. So this everything in the parenthesis is just the magnitude of the normal force. And the force of friction is mu times the normal force. And then we choose its sign depending on whether force of friction is acting in this direction or acting in this direction. At the moment, we are considering that the car might slide upwards. So the force of friction would be negative. Okay.
So there's one thing I'm confused about. जो हमारा FC था, centripetal force, हमने उसको rightwards क्यों लिया, left की तरफ क्यों नहीं? Isn't it going around towards the center नहीं होती जो FC होती है, centripetal force की direction?
वो ना bank जो the force that is exerting, the bank is exerting on. So that's the force that the object is exerting on the surface. Okay. ठीक है ना? So there is a equal and opposite reaction force that acts on this on the car. So and again action reaction pair. Okay. So FC now would be equal to this component of the normal force, the one that is in this direction. Right? Okay, so now let's analyze this. One simplification that you can do is you can cancel M from everywhere. Right? And then whatever remains is you can solve this for V, and the condition for non-sliding, what would be the condition for non-sliding? What would be the condition that the car does not slide, does not skid?
A0.
AX has to be 0. Okay, so if you set AX to be 0, then I'm gonna use the next board now. Then would get an equation that looks like this. See this V square. Is equal to 0. Now let's say that you are on the ramp, okay? And there is the car has no speed, okay? 0 speed. Let's take the 0 speed case. V equals 0, okay? The car is just standing on the bank. Then this term would be 0. And this term would also be 0, right? Okay, so we would be left with 2 terms. And remember, where is this term coming from?
Acceleration.
Weight of the car, okay? The component of the weight of the car that is dragging it down the slope, pulling it down the slope, parallel component of the weight, mg sine theta. And where is this term coming from?
The weight.
No, this is the friction part. Friction part, okay? Now, since we have removed the centrifugal force and taken the car standing, the only external force, the non-frictional force, is the weight along the surface, okay? If I could pull down the figure here, we say car is standing here and it's not moving. So all the contributions coming from its angular speed are gone. The only component, only force that is acting on it along this direction is its weight. And in this case, the friction should be opposing this motion upwards. All right. So here, when car is not moving, this goes to zero, this goes to zero, and these two terms must have an opposite sign. Okay, we must write g sine theta, the acceleration downwards, and the opposition. I mean, it's just that I have taken m out. Otherwise, this is the force of so the weight acting along in the parallel to the bank, and this is the opposing friction. So this remains negative. This becomes positive. Mu g cosine theta equals to 0. Now this is the condition for not sliding down when the object is not moving, when the car is not moving. So if you simplify this, this turns out to be something that we are already familiar with. Mu. If the car is not moving, yes.
आपने ऊपर वो जो साइन था म्यू के आगे वो नेगेटिव था, वो आप नीचे लेकर आए तो आपने उसको पॉजिटिव कर दिया।
हाँ हाँ कर दिया है। क्यों किया है?
फिर आपने कहा तो था उनके दरमियान ऑपोजिट साइन होने चाहिए, लेकिन अगर आप ये जी साइन थीटा को जीरो वाली साइड पे ले जाएंगे तो ऑटोमेटिकली इनके ऑपोजिट साइन हो जाएंगे विदाउट चेंजिंग द साइन ऑफ म्यू।
नहीं, लेकिन फोर्सेस को इस तरफ ऐड करना होता है ना, ये देखें opposite side वाली पे साइन नहीं चाहिए।
Here the forces need to cancel out, so they need to be in opposite directions for there to be no acceleration, so that there's no net force.
Yeah, so in this way they are opposite in opposite direction. Okay, this is minus and this is plus. देखें ये बहुत सिंपल है, हमने ब्लॉक के केस में भी किया है। देखें ये बिल्कुल ये सिचुएशन है, ये थीटा है, ये ब्लॉक पड़ा हुआ है, ठीक है। तो अब इसके वेट या नीचे एक्ट कर रहा है, तो एक कंपोनेंट इसका किधर होगा, along this direction, और एक कंपोनेंट vertical to the surface होगा, एक parallel to the surface होगा, तो it can drag it down. Okay, the force of friction is acting in this direction. Okay, so what is the forces acting? Mg sine theta in the negative direction, if this is my coordinate system. How about the friction? Friction is in the positive direction, mu n, and for non-sliding it should be 0. Okay, sorry, this is positive. Now does it make sense now?
Yes sir.
So the weight is in this direction and the friction is in this direction, and it's a vector sum, so the signs should be opposite on the same side of the equation.
Right.
Okay, so even if car is not moving, okay, so long as the ramp theta has a peculiar value that whose tangent, if the theta is large enough that whose tangent is equal to mu, then the car would not slide down without any speed. So if the bank's angle, if the bank that the car is on is equal to theta, which is tangent inverse of mu, the car would not slide anyway. The car can enter the ramp with 0 speed and it would not skid down. Okay. All right, so this is the one interesting bit that you can learn from this equation. But let's say, now let's analyze that is not the situation. Let's say this bank, when it was designed for moving objects. They didn't want it to be too steep. And let's say that the theta given to you in this problem is less than theta max. Okay.
So shouldn't
No,
it be
sorry,
greater than theta?
greater than theta max. Okay, it's greater than theta max. Now the friction alone would not be able to sustain the car stationary. It would slide down. The moment you stop, it would slide down. So you have to maintain a certain minimum speed to not slide down. So now we would calculate that. Okay, we go back to this equation. We go back to this equation, and now we are considering, first we are trying to calculate the smallest speed that it should enter and not slide. And you see the two extreme now are becoming more clear, that if the car has speed below a certain speed, it may slide down. And if it has speed larger than a certain speed, it may skid upwards. So there is a window of speeds that the car can go on the ramp without skidding up or down. All right. So to get the lower limit, so that the car does not skid down, we must take the sign of the friction force opposite to the weight term. So the friction is acting upwards and the weight is dragging downwards. And that would give us the condition for the minimum velocity. Okay. So you change this sign to positive and then just solve this equation for V. And everything else is known to you. So you know the G, you know R, you know theta, you know mu. All right. So you have to solve this equation for V. And can you do that from here? Can someone work this out?
Sorry, sir, but are we moving or are we stationary?
No, we are moving, but we're moving with a small enough speed that if the speed is smaller than the if it is below a certain speed, it may skid down. So only thing that you have to change in this equation is to take the sign of this term positive. So the friction is acting upwards and it's stopping the skidding downwards.
Sir, can you please explain again why friction is still upwards? Because if you're applying a force Fc, won't friction be in the opposite direction to the motion?
No, because we don't know yet which way the car which way the car skids. So first we would assuming that we are entering with a small velocity, okay, that it may still skid down. Okay, we have already shown that theta is larger than the theta max. It means the friction alone cannot sustain the car from skidding. You need certain velocity, okay, that would provide an upward force and would stop it, or an upward push, and would stop it from skidding down. That is why we're taking the friction to be positive. And then when you take the friction to be negative, then you would be calculating the condition for the largest velocity that would stop it from skidding upward. You see, if you get into the ramp, there are two situations that can happen depending on your velocity. The car can skid upwards and the car can skid downwards, right?
Oh, okay. Yes.
So if your velocity is
Thank you.
small, you can skid downwards. If your velocity is large, you can skid upwards. Okay. Then we want to find both those velocities, and that would define the window of speeds with which you can safely drive over around the ramp or around the turn. So can you please work this out?
सर मेरे पास जो आंसर है वो है √GR sin थीटा माइनस म्यू cos थीटा
Under root
GR और
GR
ब्रैकेट में है sin थीटा माइनस म्यू cos थीटा over
over within the square root or outside the square root?
Inside. 1 minus mu और अलग से है sin theta. इस पूरी
Multiplied?
ब्रैकेट के साथ sin theta. हाँ, exactly.
All right. So that would be the minimum
Minimum.
speed. Minimum speed that you must enter the ramp. Okay. Now, can you calculate the V max?
Sir, V max के अंदर आपका वो sign negative ही रहेगा ना, friction वाला.
नहीं नहीं, अब positive हो जाएगा because now you suspect that it would slide upwards. Friction would be acting downward, so the friction now would become negative. ये sign लेना है अब.
सर वी मैक्स के लिए हमने अब नेगेटिव साइन से कंसीडर करना है।
जी वी मैक्स के लिए, क्योंकि अब आपको स्किड इस डायरेक्शन में होने की चांस है, तो फ्रिक्शन नेक इस डायरेक्शन में होगा. It should be a very similar expression, no?
Sir, mu का sign plus नहीं हो जाएगा हर जगह?
Yes, but can you confirm this? I think yes. Mu cosine theta over 1 minus mu 1 plus mu sine theta. Something like
Excuse
that.
me, sir, आपने ये जो ऊपर इक्वेशन लिखी हुई है इसमें आपने सबसे पहला टर्म लिखा हुआ है v square over r cos theta. I think ये v square over r sin theta है.
ये होना चाहिए.
जी, I think पहला टर्म v square over r sin theta था.
So if this is angle theta, then this is angle theta, no?
नहीं, सॉरी, तो सर मेरे ख्याल से फिर ये जो मैंने इक्वेशन आपको बताया कि शायद ये गलत हुई कि मैंने v square over r sin theta लिखा हुआ था instead of cos theta.
अच्छा ठीक है. It's all right.
सिर्फ डिनोमिनेटर का फर्क है, वो आ जाएगा cos थीटा प्लस म्यू sin थीटा, तो डिनोमिनेटर है.
Okay. So can someone again do the correct calculation?
सर स्क्वायर रूट gr ब्रैकेट sin थीटा माइनस म्यू cos थीटा.
Sin theta minus mu cosine theta.
और डिनोमिनेटर में cos थीटा प्लस म्यू sin थीटा.
And what about V max?
वो कैलकुलेट कर रहा हूँ.
Max के लिए same चीज, लेकिन the sign is flipped. जो ऊपर minus है it becomes positive और नीचे जो plus है वो becomes negative. Sir, this will be negative, the one on the bottom.
All right. So this defines a window of speeds that you can enter and not skid.
सर मेरा इसमें सवाल ये है कि अगर हम ये क्वेश्चन सॉल्व कर रहे हों तो जो आपने केस कंसीडर किया था जिसमें वेलोसिटी 0 थी, तो हम वो हमेशा कंसीडर करेंगे?
No, you don't have to. That I just wanted to make a point that I wanted to exclude the case that you could have the V0 case. If in the question, in a way, the question statement is incomplete, so I wanted to complete that. Okay, it should in principle be given to in the question that theta is larger than theta max. Okay. But since it was incomplete, so I wanted to consider that case as well, and that's the result that we have. We know already, right? So even for a non-moving object, that is the condition for not sliding. Actually, you can recast these equations in a more nice way, and then it makes much more sense. For example, can you divide this equation, this upper side, by cosine theta, and this one with cosine theta as well, both the numerator and the denominator, and then the equation would look like something like this: gr tangent theta minus mu over 1 plus mu tangent theta. I'm not sure if these expressions are exactly correct, but you see this, that if you set the tangent theta equals to mu, then the minimum velocity turns out to be 0. See? So you can get that condition. So this is only, so the minimum velocity only makes sense, it's non-zero when the tangent theta is larger than mu. Okay, and similarly this one as well, but that gives you the zero velocity limit. Okay.
सर आप वो सेंट्रीपिटल वाली बात फिर से समझा देंगे एक दफा कि हमें सेंट्रीपिटल